Here's a submission from Moosivaras, and he's just asking about just some ways to shape up the final tune. Let's take a look at the log and see if there's anything we can come up with. The log has two flights in it. The first is slow flying with the battery getting low, and the second one has flips and sharp turns with a full battery. So the second one is going to be the one we look at. There's not a lot you can tell about a tune with slow flying and gentle flying. It's not really asking very much of the tune, and so you can't really tell if it's good or if it's bad. On the other hand, it means that if all you do is slow, gentle flying, it's relatively easy to get a good tune, but it doesn't tell you much about how sharply tuned you are. So let's take a look at number 2. That'll be this one. We'll start with the gyros. And I'm going to start trying to compare the default of 30% smoothing with 0% smoothing, because if there's 0% smoothing, shouldn't we be looking at the actual data? I don't know, maybe so. So here the motors are idling, and you begin to fly. These lines are relatively thin, meaning that there's not too much vibration, or there's enough filtering, or some combination of the two. It is interesting what the yaw gyro does here. This kind of noise that comes out here, the thickness and jaggedness of the line, that'll deserve a closer look. If we go to the graph setup and set the smoothing to 0, we can see that the lines get a little thicker. They're not pencil thin anymore. And let's especially compare this blue pitch line with 0 and 30% smoothing. That's a lot of difference, isn't it? We would say this is very clean, whereas this looks very, well, it looks a lot noisier, doesn't it? I just don't know what to take from that. Should we be looking at the default lines? And if we are looking at the, sorry, not the default lines, should we be looking at, should we be looking at the default smooth lines, or should we be looking at no smoothing? If the default smooth lines are telling us what the actual, if it's noise free or not, then that's what we need to know. Is this misleading us into thinking that there's more noise than there really is, or is this revealing something that was being obscured? After all, this is what the gyro actually looks like without the Blackbox viewer adding smoothing. That smoothing is added by the viewer only. So maybe this copter isn't as noise-free as it seemed. Let's take a look at the yaw axis where this interesting jaggedness is. That's quite unusual. Yeah, so, oh wow, something is really going on there. What is that? Okay, so P-term oscillation on yaw. How do I know it's P-term oscillation? Well, it's the P-term, it's the red line, and it's oscillating. And specifically, this sinusoidal smooth oscillation is very characteristic of excess P gain. You have excess P gain on yaw, your yaw P gain needs to come down. Your yaw P gain is 9. I would take it down to at least 7.5 maybe, and see how that works for you. So that's why we always look at the gyros first, isn't it? If we go back to the gyros, and we go back to 0% smoothing, and we zoom all the way out, the pitch axis certainly looks much dirtier than the roll axis. Look at the thickness of the pitch axis. And that's very unusual because oftentimes with the weight distribution of a typical H-style or X-style quad, you'll get more weight spread out along the pitch axis than the roll axis, and the copter will be more damped on the pitch axis, and the weight is more centralized on the roll axis, and it'll be more vibration prone. But this is it's a 184 millimeter pure X. Do you actually say what kind it is? So it's a pure X like an alien, in which case the fact that the motors are arranged in an X style doesn't mean anything about the weight distribution. It's very interesting though that you have more vibration on pitch than on roll. That's quite unusual. Let's take a look at the pitch axis next. And see what we got. So here is a flip, a back flip. We see a strong lowering the throttle and moving into the move here. The P term goes negative, pushing the copter into the move. The gyro goes negative. It is interesting that as you drop the throttle, see here you've dropped the throttle, but you just now started to pull the stick back. Notice that the gyro went positive when you drop the throttle. That means the copter pitched forward as you drop the throttle. That's very interesting. You may need a little more eye gain to keep the nose of the throttle steady as you raise and lower the throttle. Perhaps, what's your eye gain? 40, 40, and 45. I usually end up with more eye gain than that on pitch. Personally, maybe take it up to 50 and see if that goes away. Then again, maybe it's so fast you hardly even notice it. Now the gyro is negative. The copter is moving backwards. It's back flipping. It's flipping backwards on the pitch axis. And here we see a relatively mild push into the move, and then a sudden spike to stop or slow down the back flip. And that's very interesting. Why didn't it push harder into the move? Maybe you're just very gentle on the sticks. Yeah, I don't know. It's interesting that you didn't get a sharper push into the move, but okay. And then suddenly at this point the copter said, "Oh, I'm going fast enough. Don't go any faster." And the P term moved to oppose the gyro and slow the move down. Now you see you get this big spike in your motors here. Here you're back flipping, but the rear motors are spiking quite high, even hitting full there for a minute, whereas the front motors are slowed down. This is not ideal. I mean, it's not terrible, but it's hardly ideal. Yeah, so I would rather have seen... It's interesting that you pushed so gradually into the move, and then suddenly you were kind of overshot and were going too fast, and the PID loop said, "No, slow down!" Right at the moment that you maxed out, actually. Yeah. And here you return to center. And again, the deceleration of the move is very gradual. You normally would expect to see a much sharper stop there. So the fact that it's such a gradual move into here suggests to me that the P gains are too low. Do we see any oscillation or other signs of excess P gain? There's some oscillating here, a little bit of oscillating here. Nothing terrible. That's actually kind of good. This is kind of more like what I would like to see more of the time. There's some oscillation there. So, some oscillation. Is this prop wash? Was your throttle low? No. Your throttle was not low. We're just seeing some oscillation here. So, maybe you don't want to raise your P. Maybe it was just a very gradual stick move going into that flip. Let's see, here's another flip. Again, as you chop the throttle, notice that the nose pitches forward. The gyro goes positive. So again, indicating you probably want some more eye gain on pitch. So very gradual entry into the move with the P term, and then suddenly the P term goes, "Stop! Slow down," rather, not stop. Now the copter is moving at about the right speed, and now end the move. So the fact that I'm seeing some oscillations come out at some of the time suggests to me that that your P term may be high enough. It does seem, just numerically, it seems lower than I would expect at 4.4. We never did address why your pitch axis was noisier than your roll axis. I don't see a lot of oscillation. I would probably go up a little on the P gain and see what happened. Yeah, I would probably give that a go. Let's take a look at roll. Nope. Roll, please. So let's find some rolls. Here's a little oscillation right here on your P term. That's good. Not too much, in other words. There's some, but not too much. Here again, the same thing. Notice here that as you chop the throttle, the gyro doesn't really do anything different than it was already doing. And that's common that the roll axis is more stable. It needs less I-term, in other words. Something about the copter's aerodynamic situation means that the pitch axis is more sensitive to throttle changes than the roll axis, in my experience. Same thing, the P-term pushes into the move. Then, as the stick reaches full deflection, the P-term abruptly tries to slow the move down. Here's some relatively big oscillation here. Not really clear what you're doing there, unfortunately. The throttle is a little low and being raised. Maybe you're turning, and it was a prop wash turn. Maybe that's what that is. If this is a prop wash turn, then I would try raising D to see if you could get rid of it or soften it a little. Yeah. So I think from what I'm seeing here, just based on what I'm seeing here, your P terms look pretty close. Notice that during their flips and rolls, your P term is pretty close to 0. And that means that the copter is roughly achieving the right angular rate. There's a little bit of back and forth as it enters the flips and rolls. It pushes into the move. Oh, now I'm going too fast, so it tries to slow the move down. But then in the middle of the roll, it's not constantly oscillating back and forth, speeding up and slowing down the move. So it feels like, all in all, and we're seeing some oscillation, but not a lot of oscillation on both axes. It feels like, all in all, your P terms are pretty close to correct. I think you can raise I gain on pitch, or at least I would, based on what I'm seeing the gyro do when you chop the throttle. Possibly raising D gain a little bit. If you're happy with where your P terms are, your P gains, then possibly raising your D gains a little bit to help try and deal with some of the prop wash oscillation might be a thing to do. But also try raising your P gains maybe from 4.4 to maybe 5.0 or 5.2 or maybe even as high as 5.5 and see if you like the way that flies better. That's what I got. Happy flying.